Howdy everyone. We're gonna calculate the limit of a rational function as x is heading off to infinity, and we're gonna do it in the case where the numerator has a larger degree than the denominator. Alright, so we will talk about this in two ways. So the first way is the following. You can factor out this lower degree here from both the top and the bottom. So that would be factoring out x to the fifth from the top, so that'll leave x squared plus 3. And then on the bottom, when you factor out x to the fifth, that'll leave a 6 plus 1 over x. All right, now you can see, of course, these x to the fifths cancel. So let's write it down. It's the limit as x goes to infinity of x squared plus 3 all over 6 plus 1 over x. And this 1 over x term is going to 0. So that lets us evaluate this limit because the top here is, well, in particular, this term is going to infinity, so as x goes to infinity. So if you add 3 to it, it's still going to infinity. So altogether, this whole thing is converging to the top trying to go to infinity and the bottom trying to converge to 6. Well, if something's going to infinity and you divide it by 6, it is still going to infinity. So the answer is infinity. Though, in case, depending how you're going to phrase things, don't forget this is a type of divergence. But it's an important type of divergence. We call it going to infinity. All right, so that's one way to do it. The main trick was to factor out the degree of the denominator from the top and bottom. Now, there's a second way to look at this problem that's a little more intuitive, so let me recopy it. The limit as x goes to infinity of x to the 7th plus 3x squared. And the bottom was 6x to the 5th plus x to the 4th. Now, the main thing to do, the way to think about this problem is, since x is going to infinity, this eventually x is huge, so x to the 7th is unbelievably huge. And adding on to it a small, 3x squared hardly matters because x to the 7th is so big. Similarly, this x to the 5th here is unbelievably large when x gets really big. I mean, you take a huge number and take it to the 5th power and it's unbelievably big. It barely notices a small x to the 4th that's been added. So it's not surprising, and this is a theorem, that in this scenario, that when you are going out to infinity, only the behavior of x to the 7th matters on top, and only the behavior of 6x to the 5th matters on the bottom. All those other terms eventually just don't matter at all. Now, you can see we've got some good cancellation going on here. So it's the limit as x goes to infinity of x squared all over 6. Okay. Now, you know that x squared is going to infinity, so when you divide it by 6, by golly, it is still going to infinity. And that's the final answer. All right, that's it. Ciao.